Welcome to the Deep Dive. Today, we are pulling back the curtain on the true pioneers of the digital world.
Yeah, the people whose radical ideas really underpin everything we do online, but who you've probably never heard of.
Exactly. They're not the billionaire household names.
That's the core tension we're looking at. Our source material, it's just stacked with these profiles of inventors, engineers, even mathematicians.
Right.
And they laid the foundation for every app, every website, every single email you send. But they didn't chase the money. They prioritized, academic research, public utility, or open standards.
So our mission today is kind of a shortcut. We want to give you a quick but really thorough understanding of these architects of the digital age.
And we're focusing on that choice they made, the deliberate choice to keep their innovations free and open.
And what's so fascinating is this recurring pattern you see.
It's a powerful pattern, foundational innovation, whether it's a mathematical model for routing data or the standard for how web pages link together. It consistently came out of non-commercial environments.
So government labs, university research groups.
Precisely. All driven by this fundamental belief that communication should be, a public good.
They basically built the highway, and then other people got to drive the Lamborghinis on it.
That's a perfect way to put it. Their work facilitated the success of thousands of companies they never founded and never really profited from directly.
Okay, let's unpack this. We've structured the dive into three main themes, sort of moving from the abstract to the visible.
Right.
So first, the core, invisible infrastructure. Then, the people who designed the user experience. And finally, the big applications that brought it all together.
Let's start with the invisible plumbing of the internet.
Absolutely. And the foundational piece of this whole puzzle, it isn't code or hardware, it's actually theoretical math.
From a guy named Leonard Kleinrock.
Yeah, our sources all point to his doctoral research in the early 1960s, where he developed something called queuing theory.
Queuing theory. It sounds incredibly dry, I know.
It does.
But it's so critical. Think of it this way. When you send data, any data, it arrives and it has to wait in line in a queue before it can be processed and sent on. Kleinrock gave us the math to predict how those lines behave.
So wait, queuing theory sounds like standing in line at the post office.
Yeah.
How does that translate to data moving on the ARPANET?
It translates directly to performance, to stability. Without his math, you just can't design a stable network.
Wait.
If too many data packets arrive and the queues get too long, the system just bogs down. It crashes. Kleinrock's models were absolutely essential for designing the entire structure of these networks. He basically wrote the rulebook for digital traffic management.
And his own story reflects that priority. He wasn't a startup founder. He remained an academic professor at UCLA, focused on teaching and research.
Right. His reward was intellectual, academic, not a nine-figure bank account.
And his story just perfectly sets up the choice made by our next pioneer, Paul Barron.
Yes. So Barron is working at the Rand Corporation around the same time, early 60s. And he conceives of packet switching.
Breaking messages into little chunks.
Little addressed chunks. It was a way to build a resilient network for data.
And the original motivation was military, right? The sources say he wanted a communication system that could survive a nuclear attack.
Correct. But here's where he makes this profound choice. It's a huge turning point. Barron realized this concept, this foundation of the internet, was just too important to be proprietary.
So he just published it
openly. And crucially, he refused to patent it. He explicitly believed communication should be a public utility, free for anyone to use.
That sounds almost naive now. To not patent something that becomes the backbone of a multi-trillion-dollar industry.
From a purely corporate viewpoint, maybe. But for Barron, the public good just outweighed any private gain. He knew that locking it down would have severely limited its potential, would have slowed everything down.
So he basically guaranteed it would become a global standard by making it free.
Exactly. He ensured the foundation was there for everyone to build on.
Which brings us to the legendary duo, Vint Cerf and Bob Kahn. I mean, they're in the textbooks, but most people still don't know their names.
And they're the ones who really connected all these dots. They take the theories from Kleinrock and Barron and synthesized it all.
Right. In the early 70s, they designed the Transmission Control Protocol,
TCP,
and the Internet Protocol, IP.
TCP/IP. That pair of protocols is what allowed all these isolated networks, like the ARPANET, to finally talk to each other. It created the unified network of networks that we call the internet.
And the sources really emphasize that their work wasn't just technical. It was like a diplomatic masterpiece.
Oh, absolutely. Their job wasn't just coding. It was this relentless negotiation.
Across government labs, universities,
and commercial companies, trying to get everyone to adopt the exact same open standards. Imagine trying to get every tech giant today to agree on a single shared language with no direct monetary incentive. That was their challenge.
And again, their careers reflect this. Public service, standardization. Surf at DARPA, the Internet Society, later Google, Con 2. They got awards, academic honors, but they consciously avoided that venture capital path.
They optimized for global utility, which ironically is why the internet was able to generate so much wealth for other people.
Okay, so let's shift gears. We're moving from the invisible protocols to how you actually interact with the computer, the front-end experience.
Yeah, from the math to the visuals, and that really begins with one person, Douglas Engelbart.
And one iconic moment, his 1968 presentation, which everyone now calls the mother of all demos.
It is almost unbelievable what he showed off in that single demo.
I mean, the mouse, graphical windows, hypertext links, which is the basic idea of the web.
And even collaborative real-time editing, the principle behind things like Google Docs today. He basically invented the modern office desktop experience.
But he never started a company to sell any of it.
No. His funding came from the U.S. government, from Xerox PARSE. His goal was philosophical. He called it augmentation, extending human capability through technology.
Hold on, if Engelbart invented all that, the mouse, Windows, the core of the GI in 1968, why did it take Apple and Xerox almost 15 years to bring it to market? What happened?
The ideas were just too far ahead of the hardware.
Oh.
To run his system, you needed computing power that was just prohibitively expensive for anyone but a big research lab. Memory costs, processor speeds. The market simply hadn't caught up to his research.
That's a powerful lesson. Foundational research can be decades ahead of commercial viability. And that sets up our next pioneer perfectly. If Engelbart invented the concepts, Susan Kare gave the interface its personality.
She is the often uncredited iconographer of early GIs. Her work was defining the visual language that we still recognize today. Before her, computers were just these intimidating walls of text. She made them approachable, friendly even.
So give us some of the specific examples the sources highlight.
Well, she designed the original bitmap icons for the Apple Macintosh. That welcoming, happy Mac face when it boots up.
That was her.
That was her. The universally understood trash can symbol.
Her too.
And even that unique cloverleaf command key symbol, she created that entire visual vocabulary.
So the woman who literally dictated how computers would look and feel friendly to millions just worked as a freelance artist and consultant.
Exactly. She earned a good living, she's very successful, but she never built a company around her design IP. She created the aesthetic, but others built the empires on top of it.
That's just a massive unsung influence. Now, we should also touch on foundational security from even before the internet. We have to talk about Joan Clark.
This brings up a really important question, about the contrast between necessary secrecy and then deliberate openness. Clark was a key cryptanalyst at Bletchley Park during World War II. She helped break the German Enigma cipher.
Right, so that work had to be secret for national security. But how does her post-war legacy connect to the open foundations we're talking about?
Well, after the war, she worked on foundational computing projects like the ACE, the Automatic Computing Engine. It was one of the earliest electronic computers in the UK.
Okay.
And she contributed hugely to programming languages, to logic, algorithmic theory, all of which became the invisible groundwork for modern security and error checking. So while her wartime work was secret, the concepts she helped formalize later became the public building blocks for academia.
So she sort of bridges that gap from the era of secrecy being paramount to win a war to the later academic push for open standards in the 60s and 70s.
Precisely. And the sources remind us she and so many others from Bletchley Park received no public acclaim, no financial reward until decades later when historians and, popular culture finally resurfaced their stories.
Moving on to our final section, let's look at the two big applications that really brought the digital world to the general population.
Email and the World Wide Web itself. The tools that made the network useful for you and me.
Let's start with Ray Tomlinson, the inventor of network email in 1971. He was an engineer at BBN working on the ARPANET, and he wrote the first program that let a message be sent between users on different computers on the network.
And the brilliance of it was its simplicity. The memorable detail, of course, is that he chose the @ symbol to separate the username from the host address.
Just because it was there and wasn't used for much else.
Exactly. He just needed a symbol that was on the keyboard but wasn't likely to be in someone's name. It's so boring, it's brilliant, and it's in every email address you use today.
And his protocol was deliberately simple. which let it spread like wildfire across research institutions.
And here's that pattern again. Tomlinson never patented the idea. He just built it and let the world use it. He continued a pretty low-profile career as a systems engineer.
Just focusing on the technical contribution.
Exactly, which allowed email to become a universal standard almost overnight.
And finally, the undisputed creator of the digital universe as we know it, Tim Berners-Lee.
Working at CERN, the physics lab, in 1989, he proposes this hypertext system.
The World Wide Web, based on 3 core standards: HTML, HTTP, and URL.
Berners-Lee's story is probably the most powerful example of our whole theme. He developed the web not in a startup, but at a European research lab. He's the one who really could have become the richest person in history.
And his choice echoes Paul Barron's from decades earlier, but on a much grander scale. What kind of pressure was he under to commercialize it?
Oh, immense pressure. The sources confirm CERN itself, his employer, was thinking about patenting the technology. But Berners-Lee fought for public access.
He fought for it to be open.
He did. He deliberately released the core software and protocols into the public domain in 1993, refused to patent any part of it. And that was the single most important decision that allowed anyone, anywhere, to build on the web without paying a fee. It guaranteed its explosive global expansion.
He optimized for adoption over profit.
And in doing so, created this global economy we now live in. He never capitalized on it. He spent his career advocating for an open web, running the World Wide Web Consortium. His focus has always been on governance, not personal gain.
That is really the through line here, from queuing theory to TCP/IP to the web itself.
It is. The pattern is undeniable. The foundational elements of the internet were successful precisely because their creators made sure they were open, unpatented, and treated as public utilities.
They focused on contribution, not capitalization.
And that allowed everyone else to build on top of their work.
So what does this all mean for you today? Their stories really offer this powerful aha moment. The biggest, most impactful innovations of our time were achieved by people who actively chose research and open contribution over chasing massive personal wealth.
It proves that sometimes the best way to achieve global success is to just give the blueprints away for free.
It's an invaluable perspective, so we'll leave you with a final thought to consider. Imagine if the command key symbol, the mouse, or the core TCP/IP protocols were patented and locked down commercially from day one. How fundamentally different and how much more restricted would your digital life be today?
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.